All right, folks, here I am, Mr. Schmidt, here with Friday, October 2nd's AP Physics lesson. We're going to be talking about projectile motion and two-dimensional motion. This is my fourth time recording this audio. Hopefully, we get it right this time. I've had audio, visual, technical problems all across the board, and then that's also thrown off my math, my algebra, so hopefully we don't make any mistakes this time. All right, so we're coming over to our two-dimensional motion where we're looking at how do things move, things like rockets or divers or tennis balls or golf balls or any of those types of things that fly through the air and map out that parabolic motion. One of the things we're going to need to realize or work with is sine and cosine. Okay, so our opposite equals hypotenuse times the sine of theta. This is for a right triangle. And adjacent equals hypotenuse, and that should say cosine theta. All right, so that is when anytime we have anything that is not vertical or horizontal, if anything is at an angle, we're going to follow those two numbers, or those two equations. Okay, our governing physics equation for all of this is straight out of last week's notes with falling bodies. Anything that's experiencing initial velocity and constant acceleration, we can use this equation. If it's being dropped with zero initial velocity and it's falling straight down, then we can use gravity to solve for time. Okay, that's a very specific situation, but it does happen frequently enough that sometimes that's worth having in our back pocket. For this equations today, we're going to use this first equation over and over again as we look to how can a diver jumping off a diving board at 8 meters per second, an angle of 6 degrees, how far will she go? So we're looking for a distance in the horizontal. Okay, this is going to be modeling the assignments we have tonight. Okay, first one, you go straight down, so we don't have to worry about anything in the x. We don't have to worry about sine or cosine. Okay, the second one is horizontal, so it will start off in the x and it will accelerate in the y. So we will have both, but again, we're going to be able to skip the sine and cosines from the beginning here. Okay, but this last one is the tricky one, and that's the one we're going to be doing an example of here today. Okay, so we're going to be trying to do this right here, and we're going to be doing it on the dot cam. Hopefully this comes out and it's in focus and it all works. All right, so we're looking at 8 meters per second, 60 degrees, 2 meters. Okay, one thing we're going to have to realize for all this, so as this tracks across, we're looking for this distance. Okay, we know this distance, we know this velocity. All right. So if we know these numbers, then we can start breaking things down. And one way to do this is to take all of our x's and all of our y's and separate them into two completely different situations. So we have distance in the x, distance in the y, velocity in the x, velocity in the y, acceleration in the x, acceleration in the y. And then the one thing that ties these two together is time. Okay, so if those are the pieces of the puzzle we're trying to fit together, and remember this is our key one, that's what we're trying to solve for. Okay, so let's start writing down what we do know. We know that this is 2 meters. We don't know that yet. We know that acceleration due to gravity is negative 9.8 meters per second squared. And we know that acceleration due to gravity in the x is 0 meters per second squared. Those two facts are going to hold true for all of this homework and anytime we have anything sailing through the air. Okay, we're not going to have too many jets or paper airplanes or anything that's going to affect this number. Anytime we have anything falling or thrown or kicked or anything like that, we have these 2 points are always going to be true because we're always on Earth. All right, so the question here is how are we going to get this? Well, if we need to know distance, probably going to need to know time. In order to find time, we're going to have to find our velocity. So we're going to have to kind of work in a spiral here. Okay, so I have 4 pieces of paper I'm going to be going through here. So this is kind of our setup. We'll keep coming back to this one. But what we want to try to figure out is if we have this 60 degrees and 8 meters per second is our triangle here, then we can figure out our Vy and our Vx. Okay, so this is our hypotenuse times our sine of theta and our hypotenuse times cosine of theta. Okay, in which case we have 8 times the sine of 60 and 8 times the cosine of 60. So if I put that one into a calculator, I should get about 6.93 meters per second. And if you know your unit circle, you know that cosine of 60 is 1/2. So this is going to be 4 meters per second. So now I can come back over here, 6.93 and 4. Okay, make sure your units are matching up. It's always a good thing if you're saying meters per second and you actually put it in distance. It's a good clue that you've done something wrong. So keep your units and keep tracking what variable you're putting it into. All right, so now we have a whole bunch of numbers here, and we had that equation. Okay, now the first time we do it, we can do it all for y's and then solve for time. Okay, remember we wanted this, so we need to find that. So first we had to be over here. So we've gotten the first piece. Now we're on the second one. It's going to take some algebra to get there, and then we'll get our third one, which will be one of the shorter steps. All right, so we started at, or we end at 0. We started at 2 meters, and we had, this is in our y, so this was Vy up here, okay? Okay, so that sets up our line here. Now, if I rewrite this, by the way, this is negative 4.9. Okay, if I rewrite this as negative 4.9, that looks a lot like that, which, if you look at the quadratic formula, you're going to see something very similar, where they can take those numbers and put them in, so I'll say plus or minus the square root of b squared minus 4ac all over 2a. Okay, now it's important you get your positives and your negatives right. You started up, you were launched upwards, and gravity pulled you down. So our signs show up, up, down. Okay, so we're going to carry those signs through here. Okay, if we're looking at our parabola, we get 1 point over here, and math would predict another point back here, but we don't have negative time. So we're only going to look for this number. All right, so now if I plug these numbers in, that's negative. Times negative. Okay, so that is our equation. You're you're going to get a lot of algebra in here, and you're going to end up with, remember, all of this was solving for this variable, okay? So hopefully we got 1.66 seconds, okay? Make sure your negatives are in the right place. Make sure when you set this up, one of the things I got wrong in the earlier question is I got these transposed, which threw out that number, which is why I got an earlier mistake on third period. Okay, all right, so now that was 1.66 seconds, which means this is 1.66 seconds. Okay, so now we can do a similar situation, only following our path back to d of x. Okay, so same equation, second verse here. Only now we want all x's. So in our earlier equation, we had all of the y's. But now we want all of the x's. So we're not going to use 9.8 here. Okay, we want to know d of x. That's the whole question. Okay, we started at 0x. Okay, and then we went 4 meters per second times 1.66 seconds plus 1/2 0 times 1.66 squared. All right, that's going to be 0. That's 0. Which is going to take us all the way to, where do we got here? About 6.6 meters, okay? So that is the number that's going to equal here. All right, so that is the process. So key facts you need to know, okay? Well, let's go from the very beginning. We're going to list what we know, keeping our x's and y's separate. We see a little triangle appear here, so we're going to focus on that triangle and use sine and cosine to get the two magnitudes of these numbers, okay? I don't want to say distance because it's measuring actually a velocity here. So we're getting the magnitude of this velocity and of this velocity, okay? So now that we know the velocity, we can use the physics equation. That is the physics right there. There's the heart of the physics. Okay, the physics points us towards some algebra tricks that we have to use, okay, which gets us our time. And then once again, exact same physics, we apply it a second time. All right, so hopefully all my tech works, all your tech works, and that you can figure out the physics and the algebra for this weekend's assignment. Okay, good luck and have a good weekend.